going to do a video of the ones you asked for, Chris. Hopefully this will help you understand it better. I also have the picture posted. Alright, here's number 21. It's a complex fraction. The way I think is the easiest way to do this is to find the common denominator of all the denominators. So let's, as you can see, this p, it looks like it doesn't have a denominator, but we always put, if it doesn't have one, we can put it over 1. Let's see, so you put this p over 1, and we can put this x over 1. Now what we're going to do is we're going to look at all the denominators, p1, p1. What do they all go into? Well, they all go into p. So our common denominator is p. So what I'm going to do is I'm going to multiply every single term by the common denominator. See, it's all p. So I'm multiplying every term by the common denominator. So here's our denominator. There's 1, 2, 3, 4 denominators. What do they all go into? They all go into 4. So I'm going to eliminate all the denominators by multiplying everything by the common denominator. Let's just do that, and once we do that, we have our answer. So here our p's will cross out if we multiply these, and we're left with m. Here, there's nothing to cross out, so all we have is p squared. Then on the bottom, our p's cross out. So these are over 1. You have to think of those as over 1 as well. These cross out, so we're left with 1 minus x times p. And that's your final answer. You can do these very simply as long as you remember to find the common denominator of all the denominators and multiply every term by that common denominator. Let's get down to 23. This one, at first glance, does not look like a complex fraction, but it has these negative exponents. Alright, write that down. So the first thing you have to do is you can't just bring x to negative 1 to the denominator because these are terms, not factors. If they were factors, if they were multiplied together, you could move them up and down. But you can't do that since they're terms. So what you have to do is put x to the negative 1 is 1 over x. Y to the minus 1 is 1 over y. And then in the denominator, it's 1 over xy. So just be careful. If it would have been like this, over xy to the minus 1, if they would have been, these are called factors, these are called terms. With factors, I could have just moved these to the denominator and made them positive. But these are terms, so we can't move those down to the denominator. So now we made it into a complex fraction, so let's do what we did for number 21. We found the common denominator of all the denominators. What do x and y both go into? Well, they both go into xy. So I'm going to multiply every single term by xy. And you know it's over 1, but we're not going to write that. So if we multiply the first one, the x's will cross out, and we're left with y. Plus, now this term multiplied by xy, the y's cross out, we're left with x. And in the denominator, the x and y both cross out, so we're just left with 1. So your answer is really x plus y. Alright, let's do the last one. This is number 25. Use elimination to solve. So we have 5x minus 2y equals 9. This is our first equation. Our second is 3x minus y equals 6. If it were substitution, we would solve probably for this y and then substitute in for that y, but it's elimination. So what we're going to do is look for a variable that we can easily eliminate. So I'm thinking it would be easiest to eliminate the y, because I could take the second equation times a negative 2, and so we would have a positive 2y in this equation and a negative 2y in this equation, and when we add them, our y's would go away. So I think that's the easiest way. Another way you could have done it is you could have taken the top one times 3, and the second one by a -5, and then you would have had 15 that would have crossed out. Look for the easiest way to do that. Hopefully you see that. So I'm going to recopy these equations. We're going to get 5x minus 2y equals 9. I didn't do anything to the top one. The bottom one, I'm multiplying everything by -2. As long as you do the same thing to every term in the equation, it doesn't change the equation's value. So we're going to get minus 6x plus 2y equals minus 12. Draw a line, add those up. This one we would get minus x. Now this is our goal. These add out, so we don't have any more y's. And that equals minus 21, minus 3. And then we can't have a negative in front to not solve for x, so we divide by -1 and we get x equals 3. That's your one answer. You always need to find x and y. So I'm going to take this, x equals 3, and I'm going to put it up here where the 3 is, where the x is, beside the 3, and then I'm going to solve for y. So we're going to get 3 times 3 minus y equals 6. 9 minus y equals 6. I'm running out of room. So then I'm going to subtract. There's two different ways you can do this. We could subtract 9 from both sides. So we get minus y equals minus 3. And then divide both sides by -1. And we're going to get y equals 3. So they both equal 3. If you're not sure about that, I don't know if this is the right answers. I didn't check, so I'm going to check them. I'm going to put them in either one of these equations. These values should work in both of these equations. This one looks like the easier one to plug into, so I'm going to put the 3 there for x and the minus 3 there for y, and see if I get 6. So 3, x is 3, 3 times 3, I'll just do that over here. 3 times 3 minus y, well y is equal to 3, equals 6. 9 minus 3 equals 6. 6 equals 6. So I checked it. These are our two solutions. If you want to be even more sure, you can put it up here. So we would get 15. 5 times 3 is 15. Minus 2 times 3 is 6. Equals 9. That's also true. All right, hopefully I answered your question. If I didn't, then please email me and let me know.